Hi, this is Jeffrey, and today I'm going to explain in layman terms one of the most basic electrical concepts, and that is the concept of Ohm's law. Ohm's law is the law that describes the relationship between voltage, current, and resistance in a circuit. So one of the most common ways of expressing Ohm's law is V equals IR. V equals IR essentially states that voltage is equal to the sum of the current times the sum of the resistance. It also states that resistance is the sum of the voltage, or the, what is the division thing called? Is equivalent to the voltage divided by the current. It also states that current is equal to voltage divided by the resistance. Now, if you don't understand electronics or you're just starting, this may seem like a foreign subject to you. But if you take V equals IR, you could actually do basic algebraic movement and find what resistance could equal and current could equal. And a real world example of this would actually be me drawing a circuit. So this is a nice, very highly well skilled drawn schematic made by a PhD in electronics engineering. You know me, right? Totally, right? It's an absolute masterpiece, but that's not really the point. So, an example of this applied would be if we had a 9-volt battery and we had 2 resistors, and we knew the resistance value as so. So we could get some data off of this. So we know that our V source, our voltage source, is 9 volts. We also know that our R total, considering that this is in series, is 1,560 ohms. So V total is 9 volts, and R total is 1,560 ohms. So if we go back here, that means our I total must equal 9 divided by 1,560 ohms, which would equal 9 divided by 1,560. It would equal 0.0057 amps, or 5.76 milliamps. So now we know V total, R total, and I total. So now let's say we want to find IR1. If you ever see a series circuit, you see? Series circuit. And you see a question asking you to find IR1. That is a trick question because IR1 equals I total. In series, current is always consistent. Same thing if someone asks you for IR2 or any additional resistors in series or any kind of attached devices. So if instead this was resistor, if this was an LED in the circuit, it would still be the exact same answer. Anyway, so now we have IR1, IR2. So now we could actually apply that and find our voltages for each device in the series circuit. So let's find VR1. So voltage of resistor 1 is equivalent to 0.0057 divided by, times 1,000, which then equals a 5.769 volts. And we can take our 2 and do the same thing. So it really is that simple. We started off having no clue what our current was, and we used basic algebraic concepts to derive what our current actually was. And then finding out our current allowed us to find our current at each resistor, which then allowed us to find the voltage of each resistor. And now to verify that we have the correct voltage at each resistor, we can simply add these two together and see what we come up with. So 3.192 plus 5.769 is approximately 9 volts, which means that all our calculations for the circuit are correct. And there you have it. That is how to solve a series circuit using basic algebraic concepts. Anyway, thank you and hope you learned something.